What if the world feels solid only because we have agreed together to trust what it shows us? Every morning begins with the same quiet ceremony. Light enters the room, a wall holds its shape, a clock advances with patient certainty. We rise inside a universe that appears dependable, almost tender in its consistency. And yet, the deeper human beings have looked into reality, the less certain that certainty has become. Beneath the calm surface of ordinary life, physics has uncovered a stranger terrain, one where matter blurs into possibility, where information may matter more than substance, and where the universe can seem less like a thing and more like an event unfolding in real time. This is not a story about proving that life is an illusion. It is something more careful than that. It is a journey through a set of ideas that have unsettled some of the brightest minds of the modern age. Questions born in laboratories, in equations, in paradoxes that refuse to go away. Over the last century, science has done something remarkable. It has made reality more precise, and in doing so, more mysterious. The closer we move toward the foundations of existence, the more the old language begins to fail us. Solid becomes statistical, distance becomes uncertain. Observation begins to look less like passive witnessing and more like participation. There is a particular loneliness in these discoveries, but also a quiet beauty. They do not simply ask whether the universe is real. They ask what we mean by real in the first place. Is reality a fixed stage on which life performs? Or is it something more fluid, more relational, more deeply tied to awareness, memory, and information than we ever imagined? So we begin here, at the edge between confidence and doubt, where science meets philosophy and wonder. And with each step forward, another familiar surface may become transparent, revealing not answers, but a deeper and more human form of curiosity. What if the smallest pieces of reality are not truly there until something asks them to be? In the early decades of the 20th century, physics entered a room it has never fully left. Inside that room, the familiar rules of the visible world began to loosen. At everyday scales, a chair remains a chair, whether anyone looks at it or not. A mountain does not flicker in and out of possibility. But deep beneath those ordinary certainties, in the realm of particles and probabilities, nature began to speak in a different voice. An electron, according to quantum theory, does not behave like a tiny marble hiding in one exact place. For measurement, it is described as a spread of possibilities, a cloud of potential locations and outcomes. Only when an observation is made does one result appear. Physicists call this the collapse of the wave function, though the phrase explains less than it seems to. It names the event, but not its meaning. Something indefinite becomes definite. Something open narrows into a single fact. For generations, scientists have argued over what this really tells us. Perhaps observation does not create reality, but merely reveals it. Perhaps the equations are incomplete. Perhaps the strangeness belongs not to nature, but to the language we use to describe it. And yet the experiments keep pressing on the same bruise. Again and again, the quantum world resists the comforting picture of a universe that is fully settled in advance. That resistance has inspired a haunting thought. In digital worlds, not every detail is rendered at once. Systems conserve effort. What is not needed remains unresolved until a user turns toward it. The comparison is imperfect, of course, but hard to ignore. At the smallest scale we know, reality seems less like a finished painting than a response. And that leaves us with a question, both scientific and deeply human. If the world becomes specific only in moments of encounter, then what does it mean to say that we are merely spectators? Perhaps, from the beginning, we have been participants in a universe that does not simply exist, but answers back. What if depth itself is a kind of beautiful misunderstanding? Imagine standing at the edge of the ocean just before dawn. The horizon seems endless. Distance feels unquestionable. Space opens in every direction with such authority that it is hard to believe it could be anything but fundamental. And yet, some of the most daring ideas in modern physics suggest that the spacious world we inhabit may not be the deepest layer of reality at all. What we experience as volume, extension, and three-dimensional presence may emerge from something flatter, more abstract, and more surprising. This possibility arose not from fantasy, but from the study of black holes. When physicists tried to understand how much information a black hole can contain, they found a result that seemed almost improper. The amount of information did not scale with volume, as common sense would expect. It scaled with surface area. That single shift changed the mood of the question. If information is the true currency of the universe, then perhaps what matters most is not the inside of a region, but its boundary. From that insight grew the holographic principle, an idea both elegant and disorienting. In a hologram, a flat surface can encode the instructions for a three-dimensional image. By analogy, our universe might work in a similar way. The world of depth and distance could be a projection of data stored on a more fundamental cosmic edge. Not an illusion in the trivial sense, but an emergent display, real to us precisely because we live within it. What makes this idea so powerful is not its poetry, but its mathematical seriousness. In certain models, descriptions of gravity in one number of dimensions match exactly descriptions of quantum fields in fewer dimensions. Two different worlds, one shared truth. The equations do not panic at the contradiction. They embrace it. And so a quiet suspicion enters the story of modern science. Perhaps space is not the stage, but the image on the stage. Perhaps what we call here and there, near and far, are not ultimate facts, but ways of perceiving a deeper informational order. If that is true, then our lives unfold inside a mystery, both intimate and immense. We are not smaller than we thought. We are simply standing inside a reality whose depth may come from somewhere we cannot directly see. What if the most unsettling idea is not that our world could be artificial, but that statistics may already be leaning in that direction? In 2003, a philosopher named Nick Bostrom offered a thought experiment so spare and logical that it has lingered far beyond philosophy seminars and academic journals. He did not claim to have discovered that we live inside a simulation. He proposed something more disciplined. If technological civilizations survive long enough, and if they gain the power to model conscious beings in detailed virtual worlds, then those simulated minds could one day vastly outnumber the minds living in an original physical reality. Under those conditions, the odds would shift in a deeply uncomfortable way. Statistically, one would expect to be among the simulated rather than the original. The force of the argument comes from its simplicity. It presents three broad possibilities. Perhaps civilizations never reach that level of technological maturity. Perhaps they do, but choose not to create such simulations. Or perhaps they do create them, in which case simulated observers become so numerous that being in the base layer of reality becomes the unlikely outcome. It is a modern argument, but it touches an ancient nerve. The fear that what feels primary to us may not be primary at all. What gives this idea its peculiar staying power is not proof, but proportion. Human beings already build digital environments, synthetic characters, and increasingly convincing forms of artificial perception. We are still at the shoreline of such technologies, and already the imagination strains to keep up. Extend that arc forward by centuries or millennia, and the scale becomes difficult to hold in the mind. A single advanced civilization might generate countless worlds, each populated by beings capable of wonder, grief, memory, and self-questioning. And yet the argument does not conclude with certainty. It concludes with humility. It reminds us that our confidence in being the first, the original, the foundational version of reality may rest more on instinct than evidence. We want the world to feel singular because singleness comforts us. But what if existence is less like a lone candle in the dark and more like one light among many, each believing itself to be the first flame? In that possibility lies not just dread, but a new measure of human modesty. What if the universe has a resolution limit, a final grain beyond which reality can no longer be divided? For centuries, people imagined space as continuous, like an endless sheet of silk that could be cut forever into smaller and smaller pieces. Time, too, seemed to flow without interruption, a river with no smallest drop. But modern physics introduced a quieter, sharper possibility. At the foundations of our measurements lie the Planck length and the Planck time, scales so small that below them the familiar concepts of distance and duration begin to lose their meaning. It is as if reality itself refuses further magnification. These are not merely tiny numbers. They carry a philosophical weight that far exceeds their size. If there is a smallest meaningful unit of space, then the universe may not be smooth all the way down. It may be granular, discrete, built from increments rather than continuity. The thought is strangely familiar. Screens are made of pixels. Digital audio is sampled in intervals. Computers advance in pulses, not in flowing analog continuity. And when we encounter a lower bound to physical resolution, it is hard not to feel the echo. Of course, the analogy can be misleading. Physics is not software engineering, and metaphors can flatter our assumptions. Yet the resemblance remains difficult to dismiss entirely. A world with a smallest length begins to look less like a boundless continuum and more like a structure with rules of construction. The question is not whether this proves design. It does not. The question is why nature should possess such a floor at all. Experiments have even tried to listen for the grain of reality, searching for signs that space-time itself may have an underlying texture. The results remain uncertain, suspended between suggestion and silence. But even uncertainty has its mood. It tells us that the old confidence in infinite divisibility has already been disturbed. And perhaps that is the deeper meaning here. We once believed that closer inspection would bring cleaner answers. Instead, at the edge of the measurable, the universe becomes less like open territory and more like a threshold. A place where our tools, our concepts, and maybe even reality itself begin to say, this is as far as you can go. What if mathematics does not merely describe the universe, but reveals the kind of thing the universe is? There is something quietly astonishing about the history of science. Again and again, long before instruments could confirm them, equations arrived first. Patterns written in symbols foretold planets, particles, waves, and fields with a precision that still feels almost eerie. Human beings, using thought alone, have uncovered structures that nature later seemed obliged to obey. It is one of the most familiar facts in science and one of the strangest. In 1960, physicist Eugene Wigner gave this mystery a memorable name: the unreasonable effectiveness of mathematics. Why should abstractions born in the human mind fit the physical world so perfectly? Why should symbols traced on paper anticipate the behavior of stars, atoms, and light? Mathematics is not made of iron or gravity or fire. It has no mass, no temperature, no scent. And yet it reaches into the fabric of existence with extraordinary power, as though reality were written in a language it already understands. This is more than a practical success story. It is a philosophical wound that never quite closes. One can say that mathematics works because we have shaped it to match the world. But that answer only goes so far. So often, the deepest equations are discovered before their physical meaning is known. Beauty appears first. Confirmation comes later. The map does not merely follow the territory. At times, it seems to predict it. For some, this suggests that mathematics is woven into the structure of the cosmos itself. For others, it hints at something more unsettling, that reality behaves with the elegance of a system built on formal rules. Not proof of artifice, certainly, but an invitation to wonder whether the universe is mathematical in a deeper sense than common sense ever imagined. And perhaps that is why these equations move us so deeply. They do not only help us calculate, they make us feel that beneath the noise of daily life, there is an order at once impersonal and intimate, cold in its logic, yet strangely beautiful. As though, in learning the grammar of the world, we are also overhearing the silence from which it was made. What if the universe did not emerge by rough accident, but arrived already balanced on a razor's edge? There is a quiet improbability built into existence. Stars burn steadily because certain forces hold in delicate proportion. Atoms endure because fundamental constants fall within extraordinarily narrow ranges. If those values were nudged, even slightly, matter as we know it might never have formed. No chemistry, no long-lived stars. No planets, no oceans, no patient evolution learning over immense stretches of time how to see itself. This is the fine-tuning problem, one of the most haunting questions in modern cosmology. The laws of physics contain numbers that appear less like consequences and more like settings. The strength of gravity, the charge of the electron, the cosmological constant governing the expansion of the universe. These values are not chosen by us, and in many cases not explained by deeper theory. They simply are. Yet together they create a cosmos astonishingly hospitable to complexity. Many scientists respond with caution, and rightly so. Some point to the multiverse, suggesting that if countless universes exist with different parameters, then one life-friendly universe need not surprise us. We would naturally find ourselves in the rare region where observers can arise. It is an elegant way of dissolving the mystery by enlarging the stage, but it also leaves a strange emotional residue. To explain the precision of this world, we are asked to imagine an infinity of others we may never touch. Another interpretation is less expansive and more intimate. Perhaps the universe resembles a system initialized with carefully bounded values, not because it was designed for us, but because any world capable of producing awareness must occupy such a narrow corridor of possibility. The unsettling part is not the suggestion of intention, it is the suggestion of a calibration. And so the question lingers. Why should reality be so exquisitely set for structure, duration, and mind? Why should chaos permit such order at all? Maybe the answer lies in physics not yet discovered. Or maybe fine-tuning is one of those rare places where science, philosophy, and wonder all reach the same edge and simply stand there looking into the same bright uncertainty. What if the silence of the cosmos is not a tragedy, but a clue? On clear nights, the sky feels crowded. Light from ancient stars arrives in such abundance that emptiness seems impossible. Modern astronomy has only deepened that impression. We now know that planets are common, that many stars likely host worlds, and that some of those worlds orbit within conditions gentle enough for liquid water and perhaps life. By every intuitive measure, the universe should be full of voices, not necessarily friendly voices, not even nearby ones, but something, a signal, a structure, a sign that intelligence has appeared elsewhere and left its mark. And yet, the great quiet remains. This is the Fermi Paradox, named for the simple, devastating question often associated with physicist Enrico Fermi. Where is everybody? Given the age and scale of the cosmos, even slow-moving civilizations could, in principle, have spread across enormous distances long before humanity learned to build radios. The ingredients seem available. The time has been ample, but the sky, for all its beauty, has not answered back. There are many possible explanations, and none is fully satisfying. Perhaps life is rare after all. Perhaps intelligence is common but short-lived, undone by its own tools or by the fragile conditions that gave rise to it. Perhaps the distances are so immense and the windows of overlap so brief that civilizations pass one another like ships in fog. These are sober possibilities rooted in humility. But another interpretation has a peculiar elegance. In a constructed reality, detail does not always imply fullness. A landscape can be rich and visually complete without containing independent centers of experience in every direction. The stars may be real to us as scenery is real within a story, meaningful, measurable, emotionally powerful, but not necessarily inhabited in the way we assume. Vastness may be part of the architecture, not evidence of population. That idea may be wrong. It may only reflect our discomfort with cosmic solitude. Still, the silence changes us. It asks whether the universe is empty or whether our expectations of what fullness should look like are too human. And somewhere inside that silence is another possibility, that the search for others has always also been a search for the shape and purpose of our own existence. What if distance is not as deep as it feels? In 1935, Albert Einstein and his colleagues described a quantum phenomenon so unsettling that Einstein himself recoiled from its implications. Two particles once linked could remain connected in a way that ignored the ordinary rules of separation. Measure one, and the other responds with perfect coordination, even across distances so vast that no signal, traveling at the speed of light, could possibly bridge them in time. Einstein called it spooky action at a distance, a phrase that still carries the sound of disbelief. For decades, many hoped the strangeness would dissolve under better explanation. Perhaps the particles carried hidden instructions all along. Perhaps some unseen mechanism restored common sense behind the curtain. But experiment after experiment narrowed those exits. The world did not return to the old comfort. Quantum entanglement remained, not as metaphor, but as one of the most rigorously tested features of modern physics. What makes entanglement so difficult to absorb is not only its speed, but its indifference to spatial separation. Space, which governs so much of our experience, seems here to lose authority. The particles do not appear to communicate through the world in the way ordinary objects do. Their connection feels prior to distance, as though what we call apartness matters less at the foundation of reality than it does within the world of tables, weather, and flesh. This has led some thinkers to a deeply suggestive possibility. Perhaps space is not the ultimate framework in which things exist. Perhaps it is a layer of presentation, a way reality becomes available to creatures like us. In that view, entangled particles are not violating distance, so much as revealing that distance was never the deepest truth to begin with. There is something both unsettling and strangely consoling in that idea. It suggests that the visible world, for all its beauty, may be a surface, not false, not trivial, but incomplete. And if separation is less absolute than it seems, then perhaps the universe is held together by forms of relation we are only beginning to glimpse. The question is no longer how particles stay connected. It is whether connection, rather than distance, is the more fundamental fact of existence. What if memory is not the faithful archive we imagine, but a shoreline where reality and interpretation are always meeting? Most of us live by memory more than we realize. It is memory that tells us who we have been, whom we have loved, what the world once looked like before it changed its clothes. Memory gives continuity to a life. It stitches one day to the next and lets the self feel like a single traveler moving through time. And yet, anyone who has looked closely at remembrance knows how fragile that stitching can be. We revise, we omit, we soften edges, we inherit details from others until they feel like our own. The phenomenon known as the Mandela Effect unsettles people because it turns that private fragility into something collective. Large groups of strangers remember the same detail incorrectly. A name spelled differently, a line of dialogue that seems fixed in the mind but does not exist in the record, an event recalled with confidence, though history tells another story. On the surface, these are simple errors, the ordinary drift of recollection. But their emotional force comes from their consistency. It is one thing to misremember alone. It is another to discover that thousands of others seem to carry the same ghost of an alternate past. There are grounded explanations, and they deserve respect. Human memory is reconstructive, not photographic. Minds are shaped by suggestion, repetition, expectation, and cultural echo. Similar mistakes can spread because people are not isolated recorders. We are social rememberers. Our memories brush against one another and sometimes settle into shared distortions. And still, the deeper unease remains. The Mandela Effect fascinates not because it proves reality has changed, but because it reveals how uncertain our access to the past has always been. We move through life assuming that memory preserves what happened. In truth, it preserves what could still be carried. Perhaps that is the more human lesson. Whether these anomalies are cognitive artifacts or something stranger, they expose the delicate partnership between mind and world. Reality may be stable. Our grasp of it is not, and in that gap between event and recollection, an old question waits quietly for us. When we say we remember, what exactly are we holding on to? What if the universe cares less about objects than about the information they contain? Black holes once seemed like the ultimate symbols of disappearance. A star collapses, matter falls inward, light itself cannot return, and what crosses that threshold appears lost forever. For a long time, this felt like a grim but simple picture of nature. Some things vanish beyond recovery. But in the 1970s, Stephen Hawking complicated the story. Black holes, he showed, are not entirely black. They radiate. Over unimaginable spans of time, they can slowly evaporate. That insight opened one of the deepest crises in modern physics. If a black hole eventually disappears, what happens to the information carried by everything that fell into it? Quantum theory insists that information cannot simply be erased from reality. The details of a system may become scrambled beyond practical retrieval, but they are not supposed to be destroyed, and yet a black hole seemed to threaten exactly that. Matter enters. Radiation leaves. The original pattern appears gone. For decades, physicists wrestled with the paradox, not because they enjoy abstraction, but because the stakes were enormous. If information can truly vanish, then some of the most trusted principles in physics fracture at the foundation. A more recent work has pointed toward a subtler resolution. Information may survive after all, distributed in ways almost impossibly delicate, woven into outgoing radiation through patterns of entanglement too fine for ordinary intuition. What looked like erasure may instead be extreme transformation. This matters beyond black holes. It suggests that information is not a secondary feature of the world, a convenient summary pasted onto physical events. It may be closer to the core. Matter changes form. Stars ignite and collapse. Galaxies drift apart. But information seems to demand preservation with a stubbornness that feels almost architectural. And that leaves us with a remarkable possibility. Perhaps reality is less a collection of things than a choreography of encoded relationships. Perhaps what endures most fundamentally is not substance, but pattern. If so, then existence begins to resemble not a pile of material objects, but a vast and patient act of keeping track, as though the universe beneath all motion and fire is made of memory more than matter. What if the world is not built from things, but from questions being asked and answered? By this point in our journey, a pattern has begun to emerge. The universe, as modern thought encounters it, does not behave like a blunt collection of solid objects resting in empty space. It behaves more like a web of relations. Observation matters. Information endures. Distance softens. Depth may emerge from hidden boundaries. Even memory, that most intimate keeper of continuity, turns out to be less like a vault than a living reconstruction. Again and again, reality appears less fixed than responsive. This does not force us into a single conclusion. Science is not served by replacing one dogma with another, but it does invite a shift in sensibility. Perhaps the old mechanical image of the cosmos, so useful in its time, is no longer sufficient for the subtler questions. We may need a language that allows reality to be dynamic without being arbitrary, structured without being simple, mysterious without becoming mystical. There is something profoundly human in this threshold. We have long imagined knowledge as a lantern carried into darkness, revealing stable objects one by one. Yet what if understanding is also participatory? What if inquiry itself is part of the world's unfolding? Not because the mind invents the universe, but because the universe, at certain scales, seems to withhold final form until relationship occurs. In that sense, every act of attention becomes more than passive reception. It becomes encounter. And maybe that is why these ideas continue to haunt and nourish us. They do not merely threaten certainty, they enlarge wonder. They remind us that truth may not always arrive as a hard surface we can strike with confidence. Sometimes it comes like a horizon, receding as we approach, inviting not surrender but deeper patience. So before we end, one final possibility waits in the quiet. Perhaps reality is not a static answer hidden behind appearances. Perhaps it is a living conversation between structure and perception, law and mystery, world and witness. And if that is so, then the deepest question may not be whether the universe is real. It may be what kind of reality requires our presence in order to be fully known. What if the real discovery hidden inside all these theories is not about the universe at all, but about us? Human beings have always lived between two longings. One is the desire for stability, for a world that can be trusted to remain itself when we turn away. The other is the desire for mystery, for the sense that existence still contains undiscovered chambers, that reality has not gone flat beneath the weight of explanation. The modern age promised, for a while, that science might satisfy the first longing completely. It would name the parts, derive the laws, close the case. But the deeper the investigation has gone, the more it has revived the second longing instead. This is the quiet reversal at the heart of our story. We began by asking whether reality might be stranger than it appears, perhaps informational, perhaps relational, perhaps rendered through structures more subtle than ordinary perception can grasp. Along the way, we encountered paradoxes that did not simply challenge old assumptions. They changed the emotional atmosphere of knowledge itself. Certainty gave way to humility. Explanation opened into wonder. The universe became less like a machine we had nearly finished understanding, and more like a text whose meaning deepens every time we believe we have reached the final line. And perhaps that is why these ideas resonate so deeply beyond laboratories and equations. They speak to an old intuition that being alive is not the same as having everything resolved. We are creatures who build telescopes and particle detectors, but also creatures who remember imperfectly, who ask questions larger than survival, who feel awe before the night sky even when no answer comes back. Whether the cosmos is a simulation, a hologram, an informational field, or simply a physical reality stranger than our inherited language can hold, one fact remains unchanged. We are the beings within it trying to understand what understanding means. That effort is not small. It may be the most dignified thing we do. To search without certainty, to measure while knowing that mystery remains, to live inside unanswered questions without reducing them to fear. And as we move toward the end of this journey, a final thought begins to gather. Perhaps the deepest mark of reality is not that it can be proven, but that it continues to awaken curiosity in those brief and fragile minds that call themselves human. So where does that leave us? After all the equations, all the paradoxes, all the careful steps along the edge of what we think reality is. Not with a verdict, not with a final unveiling. The most honest conclusion is both simpler and more profound. We have discovered that the world is far less straightforward than it appears from the vantage point of ordinary life. Matter may be inseparable from information. Observation may be more entangled with reality than classical thought allowed. Space and time may not be the unquestionable backdrop we once imagined. And memory, that intimate thread by which we hold our lives together, may be as interpretive as it is faithful. None of this proves that the universe is unreal, but it does challenge the old confidence that reality is merely what sits plainly before us. There is, strangely, comfort in that uncertainty. It reminds us that mystery is not the enemy of knowledge. Mystery is what gives knowledge its horizon. Without it, science would become bookkeeping. Philosophy would become decoration. Wonder would become a childish thing to outgrow. But the universe has refused to become small for us. Even now, in an age of astonishing instruments and extraordinary theories, it remains wider than our answers, deeper than our models, and more subtle than our metaphors. Perhaps that is the final human insight hidden inside this journey. Whether reality is foundational, simulated, projected, or something for which we do not yet have language, our experience within it still matters. Love still matters. Loss still matters. Curiosity still matters. A sunset is not diminished because physics complicates what light is. A memory is not emptied of meaning because the mind reshapes what it keeps. The value of a life does not depend on whether the cosmos is made of particles, code, or something stranger still. It depends on how fully we awaken within it, and so we end not with an answer but with a question, ancient and renewed. If reality is deeper than appearance, if truth is larger than certainty, then how shall we live inside that mystery? Perhaps the finest response is neither fear nor control, but attention, to look closely, to think carefully, to remain humble before what we do not know, and to recognize that in a universe this strange, the most remarkable thing may be that it has produced beings capable of wondering about it at all.